All right, good morning. So just a reminder, if you were in class on Monday and Tuesday, you've already seen this. So this is something to refer back to if you need it, but there's no need to watch the lesson again. So just remember, a quadratic equation is really just an equation that's got a greatest exponent of 2, and it produces a parabola, which is this, a U-shaped curve. And if you remember, the vertex is either the highest or the lowest point on the parabola. So in this case, if we look, that's clearly the lowest point, and that happens to be at 0, -4. That's my vertex. On graph 2, it's clearly the highest point, and that's the point 1, 8, and that's my vertex. All right, the second piece is we have x-intercepts. So remember, the horizontal axis is our x-axis. And so in this case, my two x-intercepts, if I wrote it correctly, would be -2, 0, and 2, 0 in this case. And I'll write x-int for short. And then here, you can see that -1, 0, and 3, 0. Those are my x-intercepts for graph 2. All right, so those are the three key pieces we need. So if I go down to graphing formats, here are three possible formats for a quadratic equation. Standard form we're going to get to later. It's not all that useful for graphing, and so I'm going to ignore it for now. What I am going to think about is factored form and vertex form. So in factored form, I left these blanks here because that's where my x-intercept is going to go. In this A, we're going to find that with the graph. The key is that A stretches and can flip my graph. So if you notice here, looking at these two parabolas, one is clearly flipped compared to the other. And if you notice, this one's kind of stretched out more than this one is. And so it turns out that our A value is going to control that in each case. All right, so now I'm going to think about this. We're going to look graph 1. We're going to take a look at factored form for graph 1. So once again, once my screen clears up here, notice how -2, 0 and 2, 0 are my x-intercepts. And so I'm going to leave a blank here for A. I don't know what A is yet. But for my x-intercepts, as I said, -2 and +2, those are my x-intercepts. And so if you notice in the format, I put in a -2 and a +2. So if we go back to, only if I can see here, we go to a Desmos graph. Notice how I put in all of my points for graph 1. And now, if I type in x minus -2 and x minus 2, what do you know? I have this parabola that goes through all of my points. And even though there's not a number here, remember, we can assume that there's a 1 in front of parentheses. And so my A value is 1. I didn't need to change it. So when we're experimenting with an A value, start with A is 1, and then decide from there, do you need to expand or shrink? So what I mean is, let's say we had to stretch. I did a 3. Notice how that stretches a lot. But there's nothing that says I can't turn that into a fraction, for example. And notice how that continuously kind of flattens or stretches in a different direction. So keep that in mind, because we'll see a case where that matters very much in just a minute. But anyway, now I have this equation. That's my quadratic equation. And so I now know that a 1 goes in front. If I wanted to simplify, because I see this minus a negative, the nicer looking form would just be to have an x plus 2 and an x minus 2. This would be my nicer looking quadratic equation. All right, so that's factored form for graph 1. Let's now take a look at factored form for graph 2. So same idea, notice how -1 and +3 are my x-intercepts. So sure enough, I'm still going to leave that blank for a, don't know what it is. But I have -1 as one x-intercept, and I have +3 as another x-intercept. So I'll have x minus -1, and I'll have x minus 3. Now the question is, what's our quadratic equation? So I'm going to turn this off. Graph 2, let's turn on the points. And you'll see I have my -1, 0, my 3, 0, and my 1, 8. I've got all the points for graph 2. So now if I type in my x minus -1 times x minus 3, I get a curve that's facing upward, and clearly it needs to be facing downward. Remember, there's technically a 1 in front here, so my first change might just be to make it -1. Notice how all that happened was it flipped upside down. So when I changed from positive to negative, it flipped my graph. Now, it's still going through my 2 x-intercepts, I'm good there, but it hasn't yet hit this vertex that I want. But notice how the height is currently at 4. I want it to go up to 8, so if I think about that, I might just want to double it. So instead of a -1, maybe I make it a -2 for a. And sure enough, now it's hopped up to where it needs to be. So once again, this value in front, depending on if I wanted to cut it in half and shrink, I could make it a 1/2. But because I needed to stretch it vertically, I needed it to get taller, I use 2 to double it. I could triple, I could quadruple, but I'm just looking for the a value that makes it go through all 3 points in this case. All right. So now if I go back to my paper, I now know that for graph 2, it had to be a -2 for a. And once again, I'm just going to write this a little bit nicer by saying that x minus -1 is really an x plus 1. And now I have this quadratic equation for parabola 2. That's it. All right. Now the other thing is vertex form. So what I want you to know is that a standard is to call the vertex the point hk. So if you notice, there's an h here and there's a k here. But sometimes it's nice to think like we have been versus like a box and a triangle, and we're trying to figure out what goes in those. So a vertex you can easily also think of as just box, triangle, x value, y value. All right, so with that said, if we take a look at graph 1, notice how my vertex is at 0, -4. So I'm going to leave a blank, and now I'm going to have an x minus. Since the vertex is 0, -4, that means the box is going to be 0. And in my triangle is going to go that -4. All right, so let's take a look at graph 1. Turn our points back on. So right now we have y equals blank times x minus 0 to the second power plus -4. And what do you know? Already this matches. And just like before, remember in front of parentheses, I can assume there's a 1. Nothing changes. So that means my a value is 1. So once again, my vertex went in here. And if I wanted to write this more simply, instead of plus -4, I could always make it just -4. So now I know my a value is 1. And the key here is that notice how there's an a in both formats. A is going to be the same in both formats. So since a was 1 here, notice how a was 1 in vertex form as well. So to write this more simply, this would be my final nicer looking form. Technically, you don't even need the 1. It doesn't change anything, but for format's sake, we'll keep it there. All right. Finally, let's look at graph 2. So if you notice, graph 2, my vertex is at 1, 8. So going back to this format, we'll leave a blank for A. I suspect you might know what that will be. But in this case, my x value is 1, my y value is 8 on the vertex. So that's what's going in for h and k. And now, let's take a look at the graph. Get rid of that. All right, I got my points for graph 2 again. And if you notice, I now have an x minus 1 to the second power plus 8. Well, clearly this isn't working because it's upside down. It does go through my vertex, which is great, but it's clearly not facing the right direction. So let's turn this a value into a negative 1. All right, so now it's flipped. It's looking closer, but it's not quite matching. And so if I think about it, I want it to stretch vertically. And so notice how it got thinner because I stretched it. And now it goes through my 2 x-intercepts as well. So now I have a correct equation. And once again, notice that a value is negative 2 here. And that perfectly matches my a value from the other format. So now I know negative 2 goes in here. So in a nicer looking format, there's my vertex form. All right. So all of that is essentially, these are the 2 formats that are going to be most useful for graphing because they take advantage of x-intercepts in this case, the vertex in this case, and then use Desmos to help you figure out the a value. Eventually, we'll learn a way to find the a value exactly, but what I want you to get comfortable with is how a forces the graph to behave. All right. So if you take a look at the assignment on parabolas, go full screen here, make it easier to see. All right, notice how it tells you to type in y equals x to the second. Oddly enough, that seems to match. So what I want you to understand is that our vertex here is at 0, 0. So technically, this would be my equation. The vertex is 0, 0, and the a value in this case has to be 1. This y equals x squared only works because x minus 0 is really just x. And so this whole thing here can be simplified to x squared plus 0 is still just x squared. So once again, this is a simplified version of the vertex form. All right. Now, with that said, when you're thinking about one like this, I think this red curve follows exactly what I was saying before. So let's take a look at blue. Notice how in each case the vertex is changing. So if I use my format like I outlined before, notice how if I type this in like this, it goes right over the red curve. But I know my vertex should really be up at 0, 3. So this 0 isn't going to change. The y value of that vertex should be 3. And now I have this equation that perfectly matches for challenge number 2. So if you use this format, I think that's going to be very helpful for green, orange, and purple. All right, with that said, so same thing here. If I think about what red is for challenge number 3, I'm just going to go, once again, you can see my vertex is 0, 0, and that's what it's saying. It should pass through the origin. The orange, jeez. All right. Now, their a value I'm arguing is actually 3. And sure enough, now I have this blue curve that goes over the red one. Now, I want it to actually go through the blue points. So at least it goes through the right vertex. But now I'm thinking I probably want to experiment with A. If I make it 2 or I make it 1, notice how it's getting wider, but not wide enough. And I mean, if I go into the negatives, all that's going to do is flip my curve over, and that's not what I want. So in something like this, remember, you do have fractions available to you. So notice how when I make a fraction, it keeps getting wider. 1/3 gets even wider. So if I'm you, keep experimenting, and I'm arguing there will be a fraction that eventually makes it go through these 2 points. And finally, if I look at challenge 5, it wants you to do 3 different parabolas that go through these 2 points. Notice how this is right on the x-axis, and so in this case I have an x-intercept of -4 and an x-intercept of 3. So if I think about the format for red, for example, this is saying that -2 and +2 are x-intercepts, and notice how it goes through to -2, 0, and 2, 0. Clearly not what I want. So remember, -4 is one of my x-intercepts, and by changing this, I'm going through one of them. +3 is the other. By changing this, now notice how red goes through both of them. So as you think about how to fix this one, I would think about this format and how it might apply to the other ones. All right, those are my tips. If you are just starting this or you're wrapping it up, make sure you at least get through challenge number 8 by the end of today. Otherwise, let me know if you have questions.